Hey guys, this is EdRoh. Today we're going to be building this mint website from scratch where you can fully mint through a working smart contract, and we'll do all the styling to get your website looking like this. We're going to be using React, Ethers, and Hardhat along with some other useful plugins that will help us guide us to build this fully made website. All right, let's get started. So here I am. I'm in a new directory. And I am in a code editor called Visual Studio Code, but you can use whichever code editor you want. And the first thing we're going to type is npx create React app full mint website. Create React app is a package that allows you to build all the necessary boilerplate to create React apps. And it's very convenient and very easy to use. All right, and then from here, we're going to go into the folder we just created, and we're going to open that up into a new window. And as you can see, we already have a lot of these files created. But before that, we're going to be installing a few things, and we're going to start that with npm i-d hardhat. By the way, you're going to have Node installed. If you haven't, you can go to the Node link in the description below to install Node if you haven't already. And here we're installing Hardhat, which is a very convenient package that allows you to do a lot of the blockchain stuff, like deploy your contract, compile your contract, and it sets up a lot of that boilerplate for you. And with that installed, we're going to run a command called npx hardhat. And we are going to create a basic sample project by hitting enter, 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 and enter. And this will install a lot of the boilerplate that will help us create a Web3 application. A lot of these packages allow us to develop a lot of the things that we are going to need for our minting website. And once that's installed, we're going to install just a few more things. We're going to first install something called Open Zeppelin contracts. So this helps us import a lot of OpenZeppelin standard contracts, which are very useful for our minting smart contract. Okay, and the final thing that we're going to install is actually kind of optional, but it will help us do a lot of the styling that we'll need for our website. And we're going to be using something called Chakra, as you can see here. This is a component library that allows us to use pre-built components that makes our lives easier when it comes to styling and some of the functionality. There are some trade-offs, but I will get to that when we get there. And first, what I'm going to do is I'm going to copy this line. This website you can see in the description below as well. And then you can just copy whatever this is and then just paste it into our terminal. And we'll just wait for that to finish. And with all that, everything is fully installed and we can finally get started with our coding. So the first thing we're going to do is we're going to go to our source directory. This folder is going to be holding a lot of the files that is necessary for the website. But first, we're going to just go and click some of these files, as you can see here, and we're going to be deleting them because we do not need them. And then we can go to index.js. We're going to delete report web vitals, as well as this comment below. Save that. We're going to go to app.js. And we're going to delete the header over here because we don't need that, as well as the logo that we're not going to be using. All right, after we clean that up, we're going to go to contracts, and we have a greeter.sol file. This we can actually just delete, and we're going to create a new file. And the NFT name that we're going to call just for this demo app is going to be called robopunksnft.sol. So in this file, this is our Solidity smart contract. So this is what's going to actually appear and be saved into the blockchain. And the first thing we're going to do is write spdx-license-identifier, and you can just say unlicensed. Now, these license identifier is basically a lot of legal stuff depending on what you're trying to build. And then the first thing we're going to do, we're going to do pragma solidity. And we're going to choose 0.8.4. So this will choose the version of Solidity that we want. We're going to use 0.8.4 in this case, but you can choose any version that you want with this. And then we're going to import some Open Zeppelin contracts. So we're going to import at Open Zeppelin /contracts /token ERC 721 ERC 721.sol. And this will import our contract that we can use for minting. And this is a very convenient contract, and it's a standard because it's a very secure contract that you can reuse and we can inherit. And I'll show you that in a few seconds. But we're also going to import a few other things, which are going to import Open Zeppelin contracts. And this one is going to actually be from the Axis folder. And this one's going to be called ownable.sol. So this will allow us to define functions that only the owner can use. All right, after we imported, we're going to create our contract and we're going to call it RoboPunks NFT is ERC 721 and ownable. So these two things are what we imported over here. And this contract is going to be inheriting from these two contracts, giving us a lot of base functionality that we can base our contract from. And then from here, we're going to create a bunch of variables. So these are storage variables. So the first one we're going to create is a mint price storage variable. Just note when you're using these storage variables, they are what can cost your contract a lot of Ethereum. So if you use these willy-nilly, you're going to have issues with a lot of high cost. So you have to be very careful when you create these storage variables. And you really want to minimize the amount of variable creation as well as variable changing as you need to, because this is where a lot of the costs come from. But anyways, we have to define some of these storage variables because we are going to need them. So we're going to have a total supply over here. We're going to create another uint 256 public max supply. So these variables, by the way, are uint 256. So these are basically numbers. There are different versions of uint, but for now, we're just going to use 256, which is 32 bytes. But that's the main storage you want to use for the uint to be safe. So mint price is going to be the price of the mint. Total supply is going to be the current number of NFTs while you're minting. If there was 10 NFTs that were minted, the total supply would be 10. Whereas max supply is the maximum number of NFTs that will be in the collection. So we're going to specify that to be 1,000, but we'll come to where we specify that initially. And then we're going to have max per wallet. So this will determine the max number of NFTs a specific wallet can mint. And this helps distribute the number of NFTs to more people as opposed to one person minting maybe all 1,000 of them. And that's usually not good for a collection. All right. And the next thing we're going to create is a bool, which is a Boolean, which is basically true or false. And this is going to be is public mint enabled. This will determine when users can mint. So the owner, which is going to come from the ownable contract, is going to be able to toggle this to be true or false. And this will allow minters to be able to mint. And then we're going to create another string called base token URI. So this is very critical. If you're using something like OpenSea, this will determine the URL of which OpenSea can use to determine where the images are located. And then we're going to create an address, and we're going to create it called public withdraw wallet. We're not going to code the ability to withdraw from this wallet, but this is how you would withdraw the money that goes into the contract using this particular wallet. And this is how you retrieve the funds. And then finally, we're going to create a mapping, and this is going to be address, and we're going to set it to uint 256. And this is going to be called a public variable with wallet mints as the variable name. So basically, this will determine and keep track of all the mints that will be done. So this is very important. I've mentioned in previous videos where if you track by the balance of the number of mints in the wallet is very bad. You can watch those videos, but this is so we can actually keep track of how many each wallet has minted, so they cannot mint more than the maximum specified. And from here, we're going to create a constructor function. This constructor function is the function that gets run at the beginning of the contract creation. So this will always run when you first initialize the contract or deploy it. And then we're going to pass in ERC 721 over here, and we're going to pass in Robopunks and RP. So basically, ERC 721, this contract takes in 2 arguments. One of them is the name, the other is the symbol. And then from here, we're going to initialize our variables. So 0.02 ether like this. The reason why we don't initialize over here is because this is very, very slightly cheaper, but it's not a big deal either way. So total supply is going to be 0 because that's where we start. And then we're also going to set this to be max supply equals 1,000. And then from here, we're going to set max per wallet equals 3. And now I'm going to leave a comment. You can set a withdraw wallet address. So you're going to have to specify what this withdraw wallet should be. And then the next thing we're going to do is we're going to create a function, and we're going to call it set is public mint enabled. I spelled that wrong. Make sure you have that capitalized. And we're going to pass in a Boolean is public mint enabled. And we're going to put an underscore. So the reason why we do this is to specify that this is actually an argument, and we don't want to get confused with this versus this, so you don't have naming clashes. But this is a convention that I use, so you can use whatever convention you want. And we're going to make this an external function, and we're going to pass in an only owner modifier. So this is actually coming from the ownable contract, and this allows only the owner of the contract to be able to call this function. And in this case, the owner is going to be the same as the deployer. So that's what the owner of the contract is going to be set to by default. It's going to be the deployer. You can always change it. Ownable has some functionality where you can change from the deployer being the owner to some other wallet if you wanted. But we're going to keep it like that for now. And we're going to get is public mint enabled, and we're going to set it to is public mint enabled with the underscore. So basically, this allows us to change whenever this happens. So we're going to set that to true or false. So if it's false, no one can mint. But if it's true, we're going to allow someone to be able to set that to true, and then someone can mint for sure. And then from there, we're going to create a function called set base token URI. And we're going to pass in a string, and we're going to use something called a call data. This is similar to the memory variable if you are familiar with that. But basically, this call data allows us to know that this is just going to be read. And we're going to pass in external, and this is also going to be only owner. We only want the owner to be able to call this function. And we're going to pass in the base token URI, and we're going to set that to the base token URI being passed in. So by the way, this is, again, like I mentioned before, this is a URL of where the images are going to be located. And from here, we're going to set function token URI, and we're going to set uint256 token ID underscore, and you're going to do public view override, and we're going to return string memory. Get rid of that semicolon. So this function actually exists in ERC 721. So the base token URI consists of the URL that has the images, but the token URI is actually the function that OpenSea, for example, calls to grab the images. And by default, token URI is a function that exists in the ERC 721, and it's already defined. But if you're defining your base token URI over here, we have to override this function and be making sure that we're calling the correct variable so that OpenSea has a correct URL to call. So for example, we're going to require exists token ID to make sure token ID like that, make sure the token does exist. So we're going to have an error check if it doesn't. And then from here, we're going to actually return a string abi.encode_packed, and we're going to pass in base token URI strings to string token. Let's get rid of all these, and we're going to pass in token ID and then comma .json because we're going to be using a JSON file for this scenario. And that's pretty much it. This should be strings. So basically, if you take a look, a lot is going on over here, but basically what's happening is we're taking the URL that we identified, we're grabbing the ID and placing it behind the URL and attaching .json to the end of it. So this allows OpenSea to grab every single URL of the images. It's going to call token URI for each token, and that's how your images gets displayed on OpenSea. And finally, we're going to have one more function. This is the last function we're going to create, and it's going to be the withdraw function. And this is going to, of course, we have to make sure only the owner is able to do this, so no one else can withdraw. And what we're going to do is going to look a little funky. And we're going to first identify bool success and put this in parentheses. And we're going to say withdraw wallet.call. And we're going to pass in brackets value, address, this. And then after the this, we're going to put dot balance. And from here, we are going to pass parens with quotations like that. And we're going to say require success withdraw. Withdraw failed, like so. So it's a little funky of what's happening, but basically we're grabbing the wallet, we're calling it, which is a low-level function, but this is essentially how you want to grab funds. And we're going to pass the value of the address, which is this contract, and we're going to pass in the balance, and we're passing in empty. So there's no data. So basically, this is what allows us to withdraw the funds to the address we specified with withdraw wallet. And from here, we're grabbing the success value that returns from this. And if it's a success, we're going to keep going. But if it's not a success, it's going to pass in an error, withdraw failed, and this is going to revert. So this is just a fail check just to make sure that this correctly worked. And that's pretty much it for our smart contract. This is bare bones for sure, but this is the basic functionality that you would have. And the last thing we're going to create, aside from the only owner one, is actually going to be the real mint function. So to start off, we're going to create function mint uint 256 quantity, and we're going to pass in an underscore to identify as an argument. And we're going to say this is a public payable function. So payable, by the way, is any ones that require a value transfer of Ether. So you always have to specify that for any type of function that does that. All right, so the mint function is probably the most important part of the NFT contract, and this needs to be very well audited and make sure that you have all the right checks in place so people don't abuse this, because this is the most valuable part of your contract. So the first thing we're going to do is we're going to add a require statement, and we're going to say is public mint enabled, and we're going to make sure that it needs to be set to true before people are able to mint. And that's the purpose of this require. And then from here, we're going to have another require, and we're going to say message.value, and it's going to equal to quantity times mint price. This is another check, but this one is to make sure that the user is inputting the correct value, or else if they don't put the correct value, they're going to be able to mint at different prices that you did not specify. So this is just multiplying the quantity by the mint price and making sure the value is equal to that. And if that's true, we're going to go to the next require statement, and this is going to be total supply plus quantity underscore, and we're going to make sure that that is less than the max supply. Because if it's not, we're going to error out and say it's sold out to make sure that the max supply is not exceeded. And then finally, we're going to have a require statement, and we're going to say wallet mints, and we're going to pass in message.sender. I spelled that correctly. And then we go quantity underscore, and it's going to be less than max per wallet. And we're going to say exceeded max wallet if that error. So this, like before, it determines the number of mints that a wallet can do. So this will make sure and keep track of the count and the quantity of the wallet. And you need this. You cannot go by balance of, because if you do balance of, they're going to mint, they're going to transfer or sell, and then they're going to mint again. That's a very abusive way. And this renders max per wallet useless if you do the balance of. So this is a way to make sure that doesn't happen. And finally, from there, now we can actually perform the mint. And we're going to say uint256 ui equals 0, I is less than quantity underscore I plus plus. So we're going to loop through. This is where we're going to actually do the minting. So the first thing we're going to specify is uint256 new token ID equals total supply plus 1. So this will keep track of our token ID. We're basically grabbing the total supply and adding 1 to specify the token ID that we're going to mint. And then we're also going to specify total supply. We're going to increment that. And finally, we're going to run safe mint function message. And we're going to pass in message.sender and the new token ID. All right, so there's a lot going on. Let me explain. So safe mint is a function that exists within the ERC 721. Since we inherited, we can actually call it. And we just need to pass in the address that's going to receive the NFT, and that's going to be message.sender. So basically the person that calls this function. And we're going to pass in the latest token ID because that's what this function requires. And then there's also, we have to make sure we increment the total supply to keep track of it correctly. And just to note that you should definitely do a lot of this changes before you call the interactions. So this is called a check effects interaction pattern, which right here is an effect. And you always want the effect to happen before an interaction. So effect is anytime you're changing any kind of variable in the storage. So you want that to happen before you interact, which is something like this function, so that you're preventing something called a reentrancy attack. This is very important. In this case, they probably wouldn't abuse this if this was afterwards. Chances are they probably wouldn't do that because it's not very useful or it's not very profitable for them. But just to be safe, you want people to 100% not be able to abuse it, and this will do just that. And just a side note, this is ERC 721. There's a Azuki NFT. They created something called ERC 721A, which is a little more gas efficient when someone's minting multiple NFTs. If they're only minting one, it doesn't really matter. But basically, Azuki NFT just does this in one go. They specify the quantity so they're not having a loop, and that's how it saves some gas costs. So you can take a look. It's pretty much the same idea. And there you go. That's pretty much it for this smart contract. There's a lot to it, and there's a lot of like subtle things. It's not as much code as you would write for front end, but every code needs to be solid and make sure that you do not make any mistakes. Because if you make any mistakes, this is going to go very sour. From here, what we want to do, we're going to save this, and we're going to go to scripts and go to this file. And what we're going to do, we're not going to erase everything, but we're going to erase all the comments. And from here, we're going to go and we're going to select this option so that we only select the ones that are capitalized. And we're going to call this RoboPunks, or it has to be capitalized, RoboPunks NFT. And then from there, we're going to select all the lowercase ones, and we're going to write RoboPunks NFT, but lowercase, starting lowercase. And we're going to save that. We're going to remove this string because this is relevant to the constructor variables. We are not passing anything in here. So that's why we don't need to pass in anything there. And we're going to save this, but we're also going to rename this to deploy RoboPunks NFT, just to be consistent with the naming. Now we finished all the coding for our smart contracts, but there's going to be some setup for us to deploy our smart contract. And we're going to deploy it on something called a test network for Ethereum. So we are doing this because if you deploy your contract on the real mainnet Ethereum network, it costs actual money, or basically real Ethereum that you need. So we're going to deploy it to the test network, and the one we're going to be using is called Rinkeby. So we're going to go to any browser and make sure you have MetaMask installed. And from there, we are going to choose the Rinkeby test network. If you don't have this network, you can add it over here or you can go and check in MetaMask, and you can click this button, go to settings, advanced, and you can hit this. This should hopefully open up Rinkeby into your network, but you can search if you can't find that. And here, as you can see, I have some Ethereum loaded. So this is a fake account that I've created, and you can create any account, as many accounts as you want, and use fake Ethereum in these test networks to do so. And the way you get fake Ethereum, it doesn't automatically come loaded with fake Ethereum. You have to go to something called a faucet. And in this particular link, we have the Rinkeby authenticated faucet, and you can grab some ethers from there. You've got your testnet into your wallet. The next thing we're going to do is we're going to set up an Infura account. So this is a blockchain node provider, and it's equivalent to Alchemy as well, which is another alternative. But I have registered an account on Infura already, and that's why I'm seeing this dashboard. So once you have that set up, what you're going to do is we're going to create a new project. We're going to select Ethereum, and we're going to call this test, and we're going to create this. So over here, what you can do, or what you see, is a lot of values. The main thing that you're going to be choosing is Rinkeby over here, and we're going to have this particular endpoint that we can copy. Don't use the one that I'm using, because I'm going to be deleting this project after this video is up, but you want to be able to create your own and copy this value as well. And what you're going to do is we're going to go back to our project, and we're going to create a new file, and we're going to call it .env. This .env is already ignored by the git ignore file. So when you push this up to a repo, this is not pushed up, because this will have all the sensitive information to your project. And you do not want anybody else to be able to see a lot of these values, because they're very important. And we're going to call this React app Rinkeby RPC URL. And we're going to call this what we just copied from the website. And then the next thing we're going to do is we're going to go to Etherscan. They have an API key that we're going to be using to verify our contract for later use. What you want to do is you're going to be signing in, and you're going to go to a section called API key. And in the API key, you're going to copy the value that's given to you. And I've already copied mine, and I'm going to write it over here, React app, Etherscan key, and we're going to pass that value in. Now you should do this on your own. Again, this is something I copied, and I'm going to be deleting this before this video goes up. So you want to be able to copy your own value. All right. And then the last thing that you want to do is we're going to go to any account, and we're going to go account details, and we're going to export private key. So this is very, very important. I mean, if you just created an account and you're doing this for development purposes and you're not going to use the wallet for anything else, it's not a big deal. But definitely you don't want to show your private key as much as you can. So this is going to be used so that we can actually deploy the contract. So this is the wallet that's going to be handled as the account that will deploy the wallet. And we're going to create one last thing, private key, and we're going to add over here. I'm not going to write it right now, even though it's a test account. For my own safety, I'm just going to keep it secret. So I'm gonna change this all to single quotes. I don't know if that really matters, but that's how I've done it. And you want to copy your private key over here, and you definitely don't want to show that to anyone. Now that everything is set up for the .env file, what we're going to do is we're going to open up the terminal, and there's something I forgot to install, and this is going to be the .env package. And we're going to do npm i-d, which is dev dependency, and we're going to put .env there, and we're going to install that. Once that's installed, we're going to add a few things into this file, and we're going to pass in const.env equals require.env, and we're going to initialize it with .env.config parentheses. So this allows us to actually use the .env configuration. And then from here, we're going to go down to the module exports, and we're going to pass in a networks property, and we're going to go and create an object. We're going to call this Rinkeby, pass in that URL, and we're going to be using our env file that we've created. And so we are going to use React app Rinkeby RPC URL. To be safe, you can copy the values, but I'll keep it like this for now. And then accounts, and we're going to pass in process .env.react app Rinkeby RPC but we're going to replace this with private key underscore private key. And then from here, you got to make sure for this next one, we're going to put it outside of the networks property. I keep doing that, but you want to put Etherscan outside of this networks property. And we're going to copy this section to make it easier. And we're going to pass in API key. And we're going to pass in what we've copied, Etherscan underscore key. So all of these configurations allow us to deploy the contract onto Etherscan and the Rinkeby test network and verify it afterwards. Now that we have everything set up, we can run a few commands to actually deploy our contract. We're going to run npx hardhat clean and then npx hardhat compile. So this compiles our contracts. And then we're going to run npx hardhat run scripts. And we're going to run the scripts that we actually wrote, robopunks nft.js, which is this file right here. And we're going to choose our network. And it's going to be Rinkeby, like so. And this line right here is actually going to be the line that's actually deploying the contract into the test network. And so we're just going to wait a few seconds for this to run. And here we have the contract address. So now if I go to Etherscan, and I don't think it's already up yet, but it takes a few seconds. Yeah, it's going to take a few seconds. So I'm going to wait till that happens. Okay, and now that we see it, I made a mistake before. I was actually on the regular mainnet Etherscan. You need to go to the Rinkeby test network Etherscan, and you can search that up on Google. And that's where your contract address will be deployed. Now that we have the contract address deployed on the Etherscan test network, we can look at the contract over here. We can see that this is bytecode and this is not human readable code. So we want to be able to verify this. So the way to verify, we need to install another package, npm i/d, and we're going to pass in nomic labs/hardhat-etherscan. So this allows us and gives us the verify command for the Hardhat package. And what we're going to do is we're going to add a require statement while we wait for that. And we're going to pass in @nomic labs/hardhat-etherscan. The last thing we want to do is run the command to verify our contract. So we're going to run npx hardhat verify //network Rinkeby. And we want to pass in the contract address. So we can go back here, copy this address that we have already deployed and paste it in here and give it a few seconds. Oh, sorry, this was not saved. So make sure you have the hardhat config file saved and then we can rerun it. All right, cool. And then after that, we have successfully verified our contract. Then if we go here and then we're going to refresh it, now we can actually see the contract we've created. And we can also read and write on the contract. So read is just a way to see what values that you already have. So max supply, for example, is 1,000. You'll have to connect your wallet, but this is how you can call your functions that exist on this contract. All right. And then from there, what we're going to do is we're going to go into our source folder and we're going to do a little bit of setup. And what we're going to do is if you take a look here in the artifacts folder, we have this JSON file. And what we need is this ABI. Basically, we won't be able to reference this because it's outside of the source directory. It's just how Hardhat is configured. So what we're going to do is we're going to create a new file in here. We're going to call this new file, robopunks nft.json. And what we're going to do is we're going to go over here, select all, and we're going to go into robopunks nft.json, and we're going to place everything that was in there. With all that set up out of the way, now you can see that I have an assets folder. This assets folder is in the link in the description below. So go down there, download it, and put it into your source directory. So these has some images that you're going to be using for this project. Right, and then before we dive deep into writing our code, I want to show you how React kind of works and how we're going to split our website. So if you take a look on our website or the final finished product, we don't have this yet. we can see that we can segment our application into several parts. So one is going to be separated into the nav bar, and then this main section right here in the middle, we're going to call this main mint section. And then everything that has both of these is going to be called app. So if you know a little about React, you generally want to separate your UI or what you're seeing on the website into several distinct components that you can organize. So it helps with both organization and reusability. And that's the purpose of React. It's been a long time coming, but we can finally start coding our website. So the first thing we're going to do is we're going to import use state from React. So this allows us to use different elements of state in our components. And I'll show you in a little bit what that can do. And we're going to import main mint from a main mint file. We're going to be creating this shortly. We haven't created this yet. So we're creating these components and we're importing them a little bit. And from here, we're going to go and we're going to do const accounts, set accounts like so. And we're going to use state. So if you're new to React, there's something called hooks in React, and this is use state is a type of hook. What this allows you to do is that any visual elements that change, anything that updates in the UI due to some kind of button click or some kind of update of information, in this case, it's going to be like the accounts, like their wallet address gets updated. You use state to update the address, and you can configure it so that anytime this value changes, React will know to render the right elements and components. All right. And then from here, we're going to encase this with parentheses. And what we're going to do is we're going to add a few components, and we're going to add in nav bar, and we're going to pass in accounts like so. And we're going to set accounts like so. So what this is actually doing, if you're new to React, again, is that this is prop drilling. We're passing accounts and set accounts into this component so that these components can use the same state that you've created. And we're going to do the same thing for main mint. We're going to copy this and pass all those values in so that we can use these accounts through both of these components. After that, we're going to create our navbar component. We're going to do a new file into our source directory called navbar, and then we're going to put JS. So this will be the component for the navbar, and we're going to import React from React like so, and we're going to create const navbar equals accounts set accounts. So like I said, this is prop drilling. This is how you pass in state from the top component. Note that this is in parentheses and there's a bracket within. All right. And then from here, we're going to create a variable called isConnected. So this will forcibly turn accounts 0 into a Boolean. So account 0 is going to be the address of the wallet that's going to come back in. And then we're going to set that to a Boolean. So this will detect when we're connected versus when we're not connected. And we will use that to render specific components. And then from here, we're going to create an asynchronous function, and we're going to call this connect account like so. And what we're going to do is going to pass in if window.ethereum. So basically, when you're using MetaMask injects the application with window.ethereum. So when that exists, we can check and grab the accounts that come from the MetaMask. So we await window.ethereum.request. And we're going to pass in method eth request accounts like so. So this will give us all the accounts that exist in the MetaMask wallet. And what we're going to do is we're going to set the accounts to accounts. So basically, back in app.js, we're going to update the state. So whenever this particular function happens, and when we call this function, we are going to update the accounts. All right. And then from there, we're going to return, and we're going to create some elements over here, and we're going to pass in a div, and we're going to be splitting this into several components. We're going to have the left side of the nav bar, and this will be the social media icons. This is just a comment so we can organize our code properly. Facebook, div, Twitter. We're going to actually put the images later on, but for now, we're just going to have a placeholder. And we'll do all the styling at a later part. And then right side, we're going to have sections and connect. And then we're going to have about, div, mint, div, team. And then finally, we have the connect button, and the connect button requires a little bit more logic. And so what we're going to do is we're going to check if we're connected. So basically what this is going to do is you're going to check if you have the accounts connected. We're going to show something different depending on this Boolean. So basically, if we're connected to the website, we're going to show just a basic element that shows connected. Otherwise, if we don't have that, we're going to be showing a button, and the button will, if you click it, we're going to run the connect account function that we've created. So basically, if we're not connected, we're going to run this button. We're going to run connect account. That will give us the account, and then the accounts will be updated to actually have a value. So is connected will turn true. And once it turns true, it's going to say the website is connected. And then if we take a look, what we're going to do is we're going to run the server. Now that we have the nav bar out of the way, we're going to create a new file, and we're going to call it main mint. It's a new file, main mint.js. So now we are creating this particular component that we've specified earlier. So from here, we're going to import a few things, and we're going to import use state again from React. And then we're going to import ethers and big number from ethers. So we haven't talked about ethers library, but this is a very important part of building dApp. This is a package that allows you to connect to the blockchain very easily. And that has a lot of utility functions, a lot of functions that help you connect to it, make your life easier. I'm sure you've heard of Web3 JS. So Ethers is just an alternative of that. Ethers is more of the industry standard now, and people are trending towards Ethers JS. So I recommend using Ethers if you have not already used Web3. All right, and then from here, we're going to import RoboPunk's NFT from the JSON file we created earlier. So this will allow us to grab the ABI, which is something that allows us to connect to our contract using the JSON file that we've created. All right, and then from there, we're going to grab the RoboPunk's NFT address, and this is going to be the address that we've originally specified, or sorry, not this one, but this particular contract address. So we need to specify the contract address somewhere so we can use it. All right, and then from there, we're going to create the main mint component, and we're going to pass in accounts and set accounts like we've done before with prop drilling. And we're going to pass this in const mint amount, set mint amount. So we're creating more state, use state. And in this one, this is going to determine the number of quantity that the user is selecting to mint. So it's going to be that value that you saw in the final build with the number of mints that the user is going to mint. So this can be updated via set mint amount, and we'll cover it. And it starts with 1. That's how this value, and that's why you specify this to be 1. And we're also going to get is connected again. We're going to pass in Boolean, accounts 0 like so, and we're going to use it for similar reasons. And we're going to create another async function, and this one's going to be called handle mint. So this one, we're going to do window.ethereum. And if the user is connected or has the MetaMask logged in, we're going to create something called const provider equals new ethers providers dot web3 provider. And we're going to pass in window.ethereum. So it's kind of a mouthful, but basically this provides a way for ethers to connect to the blockchain. And it's just initial setup so we can actually use it. And then we're going to create a constant signer variable, and we grab provider.get signer. So anytime we want to make an actual transaction like handle mint, you need a signer, something that signs the transaction, because those are the ones that actually, involve actual money or Ethereum to run. And then finally, we're going to create a new contract or new ethers contract, and this will actually be where you have to specify your actual address. So Robopunk's NFT address, and then we're going to pass in Robopunk's NFT.abi. So we pass in the address at first, and then we're going to pass in the ABI of the JSON that we are using. And then finally, we're going to pass in signer. So all of this is necessary so we can actually use the contract functions. And then we're going to create a try catch block. These are just ways if any asynchronous options, or if we try to run this function or anything, all the logic inside of this fails, then we're going to have a catch just in case. And it'll tell us that we've encountered an error like so. And we can pass in whatever logic we want here. And then in our try block though, we're going to have const response, and we're going to await the contract.mint, and we're going to pass in mint amount. So, and then we're going to console log the response like so, pass in the response like that. So essentially what this is actually doing is we're going to call the contract actually. So now with all this passed in, we can run this particular function over here, mint, and we're going to pass in the quantity as if we're just running a regular function. So we're going to go back here, we're going to look at this, and then the response is whatever is returned from it. The response doesn't really matter, but we're just checking if we just got the response. And the main thing to note is that we want to pass in a big number instead of a regular number from JavaScript, because Solidity requires us to have this as a big number for us to use. All right. And then from there, we're going to create a few more functions. Just bear with me. We're going to have handle decrement. And this is the function that will be run when we click the minus button for the mint amount. And we're going to have an if check right here, so that if the mint amount is set less than 1, then we're going to return. We're not going to do anything. But if it's within 1, or if it's above 1 or equal to 1, we're going to set the mint amount like so. Mint amount minus 1. So this will just handle the button that decreases the value. So it'll decrease this value as long as it's minimum of 1. And we're going to do the same thing. We're going to copy this, but we're going to handle increment. And we're going to set this to be a max of 3. And what we're going to do is we're going to increment it instead, like so. And we're going to return. And from here, we're going to do our usual JavaScript or JSX, which is just HTML in a specific format for React. And we're going to pass in H1, Robopunks. And then we're going to pass in the paragraph tag, and we're going to write some text. It's 2078. This can be whatever you want, but can the Robopunks NFT save humans from destructive, rampant NFT speculation? Mint Robopunks to find out, right? And then from there, we're going to check if we're connected again. And if we're connected, we're going to show something different if they're not connected as well. So we're going to start with a div like so, and close that div tag. And we're going to have another div, close that div tag. And we're going to do a few things. We're going to actually add the button, and this one will be handling the decrement like the function that we've created before. And we're going to pass in a minus value. And then we're also going to create an input of type number. and we're going to give it the value of the mint amount, like so. And then we're also going to create the increment. So we're going to do that by copying handle increment, and we're going to have a plus button instead. And then below all this, we're going to have another button, and this one will be handling the mint. So we're going to mint now, like so. So that will take care of running this particular mint function. And then finally, if we're not connected, we are going to have a simple paragraph tag that says you are not connected yet. Or actually, you must be connected to mint. All right. So once we have that set up, oh, and I've forgotten one thing. So we want to export default main mint like so we can actually retrieve that and import. So this part is necessary so that you can import as well. And we need the same thing for the nav bar. All right, so now we have basically the setup of the website. So we're going to do npm run start in our terminal, and we're going to be running our website just to see what we have. Give it a few seconds. As you can see, we have everything that is set up for the final layout. But this is, as you can see, doesn't look that pretty. Doesn't really have any styling whatsoever. And that will be what we'll do next. But this provides all the functionality, everything that we kind of need. So if we connect, we can see that we've connected. And that's because I've already connected to the website. But if you're not connected, it'll show a login page for yours. So if you do this, login, refresh the page, we connect, you're going to see this pop-up happen. Log in. And once we wait, now you can see we're connected. We can go up and we can go down with a maximum of 3 and minimum of 1. All right, now that we have all the setup and the structure laid out for our website, now we can go about styling our website to make it look nice. So we can go and we can go to our app.js, and we're going to add a few elements here. Div class name equals overlay. And a lot of this will be necessary so you can add some classes for CSS to style our website. And then we're also going to give another div. We're going to give it another class name, moving background, like so. And this will be used for the background image. So we're going to go into our app CSS, and most of what we have is going to be some stuff that we're going to be deleting. So we're going to go app header, app link. We're going to just delete everything below this. Same with the media and the app logo. So we don't need most of that. And the first thing we're going to do is we're going to import some Google fonts. So we're going to do @import URL https fonts google apis.com/css. So we can actually create a few font families here. You can pick a lot of this up from the Google website, and these are all free to use. As long as you import them, you're pretty much good to go. And I'm just going to copy this last one, same exact thing, v2323. These are all like pixel type fonts. These are the 2 free pixel fonts that you can use from Google. But you can always, of course, create your own or find another one, whatever you want. And once in our app, we want to specify font family to be using these 2, like so, comma, v2323, like so. And we are going to set the color to be white. So our fonts are going to be white. And once we have a background, it'll be better. And then we're going to set this as star. We're going to make everything box sizing of border box. If you're unfamiliar with it, this is essentially a way so that all the CSS is defined in a specific way where the padding is defined in the width. You can probably look it up and if you're unfamiliar with it, but it's not a big deal. So then we have a body, and we're going to set overflow to be hidden so we don't have anything left over. And then we're also going to have overflow or overlay. And we're going to set a bunch of settings over here. So we're going to have opacity, and we're going to set that to 0.85 with 100%. And we're going to set height of 100% and Z index of 10. Top is going to be 0. Left is going to be 0. Position is going to be fixed. The reason for this overlay is because the original image and art is a little bit dark, and it's also kind of not fitting together, but this overlay provides a little bit of a gray overlay, and it makes it look way better. And then we're going to have a moving background. And this is where we're going to input the moving image background that you have. So this will basically be a GIF that you want to use. But the recommended approach with this is not to use a GIF, but to use multiple layers of images that move. And there are specific articles you can search online to do it this way, to do it that way, because that will be way more performant. But if you use a GIF, the file size is pretty big, so it can kind of slow your website down. But because the images I got, which is from like a free pixel vector website that you can just grab for, and this is just, since this is just for demonstration purposes, I just put a GIF instead. And plus this video is getting really long, so we'll keep it simple in this situation. And we're going to pass in assets, background, parallax, like so, background, GIF, like that. And we're going to say background size of cover, background repeat, no repeat, like so, background attachment, fixed, and background position 40%. 40%. The reason I've already done the CSS, and that's why I'm just writing it down. I'm just copying it from what I had, but a lot of this was trial and error, and then you just kind of see. As you can see, we already have a lot of what we want to be set up. We still have to worry about main mint and navbar, which we'll get to in a sec. But we already have the moving background. It looks pretty good already. From here, we're going to close these two tabs. We're going to go to navbar, and we're going to be importing stuff from Chakra. So we install this all the way at the beginning of this tutorial, but these are component libraries that make everything very convenient to style. And it's up to you if you want to use something like this to make your life easier, but there's so many options in terms of styling, and some things make it easier, but you might get into a point where you have decision fatigue because there's so many options of how you want to go about different component libraries, or you can go just do plain CSS, or you can use different CSS packages like Bootstrap, a lot of different options. But anyways, we're going to import all of these things from Chakra UI. So these are all pre-made components that we can use. And we're going to import Facebook. So that's basically this image in this social media icon. So we're importing these assets, social media icons, Facebook 32x32x.png. So this will provide an image for the Facebook icon. So instead of having this Facebook text, we're going to be having an image for it. And we're going to do the same thing for the other two. So we're going to copy and then paste. This is going to be Twitter, and then this will be Twitter. And this will be email. Technically, this would be Discord, but there was no free Discord social media icon. So I'm using email instead. All right. And so once we have that, we can change this one to flex. So flex is a way to align things properly, and is a convenient way as opposed to just using regular flex blocks where you have to create components and then you have to create the classes as well. But using Chakra, you can directly add all these in the JSX code instead of going to like a separate file like we've done and adding these classes. So it's a nice, convenient way to write. 3 pixel, 30 pixel. Actually, this should be 30 pixel like this. So with Chakra UI, a nice thing is that you can specify the CSS classes directly inside while you're writing JSX. So you don't have to jump from file over here and specify the classes. We're gonna have the flex. Just realize with this, the only problem with this right now in this type of situation, it's not too big of a deal, but note that if you have a lot of these classes or a lot of these CSS styling, you might run into an issue where you're dealing with really messy code. From here, I'm going to start just pasting a lot of the code that I have, justify, space around with 40% and then padding. And what I'm going to do is I'm going to pass in inside here instead of what I had before, I'm going to pass in a link like so. So if you take a look, we have a reference to just Facebook, but this could be whatever URL that you want. And we are going to wrap it around an image of the Facebook icon that we just imported. And a lot of these extra flex provides the opportunity to move your icons around in the proper location. If we go here, I'm going to remove this as well. And I'm going to copy and paste. It's exactly the same thing as Facebook with just different reference as well as the source image. So if we save this and we go over here, we can see we've already have it laid out horizontally because of this flex box. And this flex creates another flex separate for this versus this one. This one is very different as well. And that's over here. And so with that, we're going to do the same thing for them. And we're going to have a flex box around that as well. So I copied a lot of this. This is space around and then align center with 40% padding. We can just have that as 30 pixel. And then below, we're going to replace this with several things called box. So box is just a way, it's just a div element, but we can write the styling right there here. So margin of 15 pixels on the left and right side is what this is saying. So it provides a way so that there's spacing between, as well as the spacer stuff provides a convenient way to do so. And then once we do that, we're going to cut that out. We're going to cut the connected part out and we're going to move it inside this flex because that's part of this guy over here. So as you can see, it kind of aligned correctly. Now we have the connect button as well. And right here, we're going to change this to a box so we can add a margin as well here to give it a little bit of more margin if we're connected. But this button, we're going to do some extra stuff because we want this to style and look good. So what we're going to do is we're going to start writing some of these styling like background color. Actually, I'll just copy this and paste it here. Now, if you take a look, I'm setting a background color to, this is like a orangey red color that fits nice. And then we have a border radius of 5 pixel, making the edges of the border round. And we have a little bit of a box shadow, so it can pop up a little more. We set the text to color white. We're going to get the cursor to pointer when you hover it. And then we inherit the font family because the font family doesn't get inherited in the buttons correctly. And then the padding and margin as well. So now if you take a look, it looks like this. It looks very nice. And it matches with the colors of the background. So a lot of trial and error in regards to that. We finished styling our nav bar. Let's go to the app or main mint. In our main mint, we're going to import a few component library or components from Chakra UI. As before, we're going to copy and paste this. Instead, what we don't need is image. We're going to change that to input because we need that one. And we're going to remove these two and we're going to put text like so. And with that, we can now go to our components and we can start modifying the styling that we have. So again, I don't want this to be just me writing code for styling because it's always going to be different depending on your application. So I don't want to spend too much time. We're going to use a flex again. So this properly formats and aligns our thing. Just realize Flexbox is very important to CSS. If you're new to it, it has a bit of a learning curve, but it is very critical to know. And then from here, we're going to create a box like so, and we're going to wrap everything around it so that everything has a width of 520 pixel. And then from here, we're going to create a div around this, and we're going to surround it with this section. So this section has a div around it. And then we're going to pass in text for H1 for RoboPunks like that. And this will allow us to customize the text. So we have a font size of 48 pixels, and we're adding some shadow behind it so it pops out a little better. And then we're also going to add another text around this guy, but we're going to add a few more. We're going to change the font family. We're changing the letter spacing. We change the size, and it has its own text shadow as well. And we're going to make sure to replace the p tag. Now, if you take a look, we have some of the text that we want in the right format. Now, if we go down, we're going to go is connected, and we're going to go into this section with the div. I'm going to replace that with the flex over here. And for the button, we're gonna have quite a bit of styling, but a lot of this styling is going to be copied to the other buttons as well. So if you take a look here, we have quite a bit of styling. Again, we changed the color, the shadow, the radius, cursor, a lot, very similar to the other button we created with the connect. And we're gonna copy and paste this essentially, except it's gonna have the handle decrement like so. So we're going to copy and paste this background color with all these values. And they're essentially this, yeah, they're exactly the same, except this handle increment versus decrement. And then finally, we're going to have some of the same stuff for input, but it's a little bit different. This is going to be read only, so we don't want to be able to type. We're going to inherit a family with 100 pixel height, text align, and all this other good stuff. And then finally, we're going to change the button to be of the same styling. Now I'm going through this fast. I know I'm copying, pasting, but this is essentially a lot of trial and error, and it depends on your design. You're going to have to modify it depending on that. So if you take a look now, if we connect, you can see that we have the buttons all working. It looks really good. And the last thing I want to do is have the text for this particular section. And then if we refresh, you can see you must connect to Mint. And you connect it, now you can see that. Okay, that was a handful. We have buttons. These are buttons that go here. We are not going to do about Mint team because this is a very long video already. So you would have longer page, and you would be able to scroll down as well. And you can connect that to the bottom or the other parts of the page as well. So now we have all the styling done. We can go connect, and if we try to mint, nothing happens. And that's for a reason. So what we needed to do is go back to our contract on Etherscan. We go to our contract, and if you notice, remember we have a is public mint enabled. Right now it's set to false by default because that's how we configured it. So now we need to connect the wallet that deployed this contract. So you have to make sure the account that deployed this contract is the one that's connected. And that can go over here, and we can set that to true. Once we have set that to true, you're going to get a transaction, estimated gas fee. We're going to set hit, and we're going to view our transaction, and we're going to be waiting for this to finish. Now, once that function is finished, we can try connecting and try to mint. And we realized this actually doesn't work. And that's because I did forget one last thing. And that is, if you go back to your handle mint function, under contract mint, you need to pass in a value. And this is going to be ethers.utils parse ether. And we need to pass in the mint price. And we're going to pass in 0.02 times mint amount, so the number of mints that you want to use, and we're going to convert it to a string. So whenever you make a function call to something that requires a value or requires an ether amount, you need to make sure to pass that in as a value. So now I'm going to save it. Now, if I go here, now I'm going to try minting too. And we can go and it works. And now we can confirm it. We can confirm it. And there you go. That's pretty much it. So once that transaction's finished, you'll be able to see your NFT and it's fully successfully minted to your account. And there you have it. That's a full minting website with a full mint contract. Everything's there. We've done the styling. That was quite a bit. And hopefully you picked up something that was helpful for you. Despite all the packages and steps that you have to go through, you have fully built a decentralized application ready for use and ready to mint. Like, comment, and subscribe if you like this comment, and I'll see you next time.